Welcome to Master Simple Physics. Today we talk about speed, velocity, and acceleration at a higher level. The graphical presentations and interpretations will continue from the last slide. In the last video, we have learned about speed and velocity, and we know speed is scalar quantity, velocity is vector quantity. Based on the velocity versus time graph, we will be able to decide accelerations. We can, based on the gradients of the straight line, determine whether it is an acceleration or decelerations. Normally, at the lower level, they will use the positive signs of acceleration as increase, negative accelerations as decrease. In the last video, we also emphasized that positive or negative signs for the vector quantity can be one direction and opposite directions, which is based on the reference point that you have set. At the higher level, it is quite commonly that represents the graph of the velocity below the x-axis. The reason is because we set the reference pointing downwards as negative. In order for you to understand what I just said, let us do these examples. A ball is released freely with an initial velocity without air resistance. First, we set the reference as upward is positive, downward is negative, hence the acceleration A equal to minus g equal to meters per square second. We use the equation V equal to U plus AT, U is equal to 0, hence V is equal to minus 10t, and plot the graph on the right. It is the straight line passing through the 0 with negative gradient. Second question, we are doing the balls throwing down with the initial velocity equal to 4 meters seconds. Since we use the upwards as positive, downwards negative, the ball is throwing downwards, therefore U must be equal to minus 4 meters per second. We use the equation V equal to U plus AT, hence V equal to minus 4 minus 10t to plot the graph on the right. Now you can see the straight line is passing through minus 4 with the negative gradient. The last example, we're talking about the ball throwing downwards. Now we use an example to explain how the ball throwing up and we make a U-turn. Right, the question is, a ball is at the reference point as shown. It is thrown upwards with the initial velocity U equal to 8 meters per second. When the ball reaches to the maximum height and makes a U-turn due to the gravitational force, the ball is then passing through the reference positions and falling further. As we set the reference point outwards, is called positive, negative is pointing downwards. So from this diagram, you will be able to see U should be equal to positive because it's the same direction of outward positions. Whereas for the acceleration, it's negative because it's pointing downwards. We use the equation V equal to U plus AT, and we substitute U equal to minus 8 minus 10t and plot the graph on the right. So now you can see the straight line is passing through positive 8 and all the way down to the negative parts of the x-axis. This negative gradient straight line is telling you that above the x-axis is one direction upwards. When the balls reach maximum height V equal to 0, it is cutting at the x-axis. Below the x-axis, we can see the ball has been make a U-turn in the downwards positions. For you to compare with the last example for ball throwing down with U equal to 0 and U equal to minus 4, we're plotting the graph on the right for you to do the comparison. We repeat the previous question shown in page 5, except now we change the reference into downwards as positive, upwards is negative. Therefore, acceleration A equal to positive g, and the initial velocity U now is become negative 8 meters per second. We know that when the ball throws outwards, when it reaches to its maximum height, the velocity is become 0. And we use the equations V equal to U plus AT, U equal to minus 8 minus 10t, and we draw the straight line is shown on the right. The red straight line cut through x-axis. That is the point that the ball reached to the maximum height with velocity equal to 0. When the ball reaches its maximum, it will change directions, and you can see the red line is sitting above the x-axis. Here we also show the green ball falling downwards with an initial velocity equal to 0, and we plot the straight line onto the right graph. The yellow ball is thrown downwards with initial velocity equal to 4 meters per second, and the straight line is drawn on the right graph. Hopefully, by now, you should be able to appreciate how to set the reference point in order to draw the graph onto the velocity versus time graph. This is a practical example to strengthen your understanding in this topic. A stone is thrown outwards from a point at the edge of the cliff. After the stone has reached to its maximum height, it falls past the cliff edge to the sea as shown. The initial vertical components of the velocity of the stone is 10 meters per second. The time taken between the stone passing the edge of the cliff on its way and hitting the sea level is 1.2 seconds. In order air resistance, what is the height of the cliff? We set the reference positive is outward, downward is negative. Hence, the acceleration equal to negative g equal to negative 10 meters per square second. Now, the initial velocity, label it as uy1 equal to 10 meters per second. And when the ball reaches to the maximum, at the top, we label it as vyt equal to 0. When the ball is returning back to its original position near to the edge of the cliff, the velocity is equal to uy2 equal to minus 10 meters per second because it's turning downwards. So the time is from the reference to the sea level is equal to 1.2 seconds. Find the height of the cliff as syc. Method 1, we are using equation to solve these problems. At the reference point, we know that outwards initial velocity uy1 equal to positive 10 meters per second. When the stone makes a U-turn and passing through the edge of the cliff, its position is similar as the ball throwing outwards. Hence, we set the velocity as uy2 equal to negative 10 meters per second. We use the first equation, v equal to u plus at. The final velocity vyc is the velocity of stone reaching to the sea level. Hence, we have the equation vyc equal to minus 10 times 1.2 equal to negative 22 meters per second as equation 1. Equation 2, we are using the v squared equal to u squared plus 2as as shown on equation 2. Then we substitute 1 equal to minus 22 and u equal to 10 and a equal to minus 10 into equation 2. Therefore, we will be able to calculate the height syc equal to 19.2 meters. Method 2, we are using the graph of velocity versus time to determine the height of the ball. Refer to the picture, we let t1 is equal to time throwing up the ball from edge of the cliff to maximum height. We assume t2 is the time for the ball dropping from its maximum height to the edge of the cliff. T is equal to the time of the ball passing the edge of the cliff to the sea level. Please note that the times of the ball throwing up from its initial positions and returning back to the same positions are the same. Hence, T1 equal to T2. Look at the pictures. We can see that the reference outwards is positive, pointing downward is negative. Hence, G is equal to minus 10 meters square second. Therefore, the gradient of the straight line equal to delta V divided by delta T equal to 10 meters per square second. Look at the graph. The upper small triangle, initial velocity is equal to 10 and the time is t1. Hence, we can express the equation of 10 divided by t1 equal to 10. Since t1 equal to t2 equal to 1 second, look at the graph. The upper small triangle and lower small triangle are the same areas as t1 equal to t2. Therefore, we can use the ratio of the small and large triangles, compare their base and the height. The ratio as shown, T2 versus T2 plus T equal to 10 versus V. Substitute the value T2 equal to 1, T2 also equal to 1 plus T, which is equal to 1.2 as given, equal to 10 versus V. From here, you will be able to calculate V equal to 22 meters per second. We presenting on the graph, V is equal to negative 22 meters per second because it's below the x-axis. The height of the cliff is equal to the green areas, which is equal to half of 10 plus V times the height is T. Therefore, we get half 10 plus 22 times 1.2, we get the answer is 19.2 meters, which is same as what we have done using the calculation methods. Before ending, let us do a revision. We hope that for now you should be able to interpret the graph with a constant gradient. In the vectors equation, the A value can be positive or negative. Therefore, it only can be one straight line up or down. For this portion, we will be able to identify whether they are acceleration or decelerations based on they cut through the x-axis. Let us look at the VT graph. The straight line is representing positive A. Therefore, the straight line is tilted upwards. From time equal to 0 to 2, which is below the x-axis, the values of velocity is decreasing from 6 to 0. Above the x-axis for time t equal to 2 to 4, you can see the values of the velocity is from 0 all the way up to 6. In order to decide acceleration or deceleration, it based on the values of velocity. If the velocity is increasing, it's acceleration. If the values of the velocity is decreasing, it means that there is a deceleration. Therefore, on the left graph, below x-axis is deceleration, above x-axis is acceleration. Similarly, we look at the right graph, it is the negative gradient straight line. The values of the velocity above the x-axis are decreasing, whereas below the x-axis, the values are increasing. So, can you identify the acceleration and deceleration on this graph? Hopefully, you will understand how to use vectors equations and plot their graphical diagram. Thank you.